In this video, we're going to keep examining what is trigonometry, but we're going to get specific with the three basic trigonometric functions, or ratios in this case. They are called sine, cosine, and tangent. They're a little bit odd names and strange spellings. You've probably seen these abbreviated at some point in your life. They're abbreviated on a calculator. They're abbreviated in the image I have on the screen. So the abbreviations for sine, cosine, and tangent are SIN for sine, COS for cosine, and TAN for tangent. Please try to refrain from calling them sin, cos, and tan. Although I know lots of people that do that, it's better to call them by their names and realize those are abbreviations: sine, cosine, and tangent ratios. So we're going to define what these are here, and hopefully you can see how it ties into previous videos that relationships, proportionalities hold true. So in each one of these examples here, in this first example, I have an angle labeled, and it's labeled with a Greek letter called theta. Looks like a 0 with a slash through it. But if we look at the angle given, notice that the side opposite it will be over there, and of course the hypotenuse above it. The sine of an angle will be defined in this way. The sine of a given angle will always be equal to the opposite side divided by the hypotenuse. It's a relationship there. So if we had numbers, we could give you specific examples, and I will in a second. The cosine for a given angle, theta, in this case I have theta here marked, will be the adjacent side divided by the hypotenuse. That's going to be its definition. And lastly, we have something called the tangent of a given angle. Tangent will be the opposite divided by the adjacent. So notice in these three definitions that it first uses opposite and hypotenuse, adjacent, hypotenuse, opposite, and adjacent. So it basically has all three combinations of the three sides there. So you can look at the relationship between those three. Let's take a look at a specific example. Here I have a right triangle, and the legs are given as 8 and 15. Notice those are the legs because the hypotenuse is this longest side opposite the right angle. If you're to use the Pythagorean Theorem first that we've discussed in previous videos, you could figure out the length of the hypotenuse, which you might want to do if you're going to use one of these trigonometric ratios that uses the hypotenuse. So if we were to solve that, 8 squared is 64, and 15 squared is 225. All right, if we add 225 and 64, we get 289 is equal to c squared. If we take the square root of that, we'll figure out, that c is exactly 17. This turns out to be a whole number here. Now, once I have the side length, I can talk about any of the trigonometric ratios depending on which angle I'm talking about. So for example, if I were to talk about this angle to the left here, and I were to give it a name, say this was point A, and I would call that angle A, then I could talk about the sine of A being, I'm going to abbreviate here, the opposite side from A, right, divided by the hypotenuse. That was the definition I gave earlier. Well, the opposite side, it would be straight across. That would be 8, and the hypotenuse is my longest length. 17. So that's all there is. The sine ratio is 8 to 17. And based on the previous video, that would mean if I made any smaller triangle inside this, it would hold that same proportionality. Okay, if I want to look at the cosine, let me zoom out just a tad to give myself some room for that. If I want to look at the cosine of A, all right, it would be defined as the adjacent side, the side next to it, divided by the hypotenuse. All right, let's see what that is. Well, if we look at our drawing here, the side next to it here is 15, and so 15 divided by the hypotenuse of 17. All right, last definition was the tangent of an angle, which is equivalent to the opposite side divided by the adjacent side. So in this case, you don't use the hypotenuse, the opposite being 8, the adjacent being 15. Of course, you could, at times, if these fractions simplify, you could simplify them. All right. Or if you wanted to convert them to a decimal, you could use a calculator. 8 divided by 17, 15 divided by 17, and so on. So actually, decimal versions of these are very, very common as well. I also want to point out that if you looked at the other angle that's not the right angle in this picture, let's see this other angle here. I'm going to call it B, the vertex B, that all of your sine, cosine, and tangent ratios would change just a little bit.